Hi everyone, I'm Professor Kelly, and this is a lecture for CSCI 308, Programming Languages Design. I'm going to be talking about explicit versus implicit typing and declaration, as well as static versus dynamic languages. Learning goals are, by the end of this lecture, you should be able to define explicit versus implicit declarations and typing, distinguish languages with dynamic versus static typing, and contrast the advantages of dynamic versus static languages. So, what does it mean to have an explicit versus implicit type? Well, let's consider first the example of explicit declaration. Here's an example from Fortran. Here, we're declaring a variable called useWin, and we're setting it to the value true. We're also declaring that the useWin variable is of the logical type. So, we have an explicit declaration of the variable useWin. We are creating this variable, and we're explicitly declaring the type of useWin as logical. Type can also be implicit. This is an example from JavaScript. Let num equals 10. Here, we aren't declaring the type of the variable. We're just saying it is a variable, but we are explicitly declaring that a variable is created. And it will have to implicitly infer the type from the fact that a 10 is being stored in it. In implicit declaration, we don't actually have to declare that a variable is being created. We just start using the variable's name without introduction. Here, for example, we are going x equals int brackets 3.14. This is a very strange example. It's strange to have an implicit declaration and an explicit type. Here we are not actually declaring that we're creating a variable, but we are explicitly declaring that the variable's type is integer. More common would be see something like this, x equals 3.14. Here, both the declaration of the creation of the variable is implicit and the type of the variable is implicit. It's a floating point number, and this will be commonly used in a language like Python. So to sum up, if variables can be implicitly declared, the language infers undefined names are an instruction to create a new variable. If variables can be implicitly typed, the language infers the type of the variable from the data put into the variable. Here's some example of implicit typing. In C, if you have a -1 or a 3.14, well, C will infer that the -1 is an integer and the 3.14 is a double. Given hello in quotation marks, C will infer that it is an array of characters. In Pascal, if we do constant pi equals 3.14, well, we have done an explicit declaration, so we are creating a new variable. However, the type is implicit, and Pascal implicitly infers that the type is real, given that you are passing 3.14 into the variable. We also have two JavaScript examples here. Let num equals 10. Well, JavaScript is using an implicit type here of number, but an explicit declaration using the let command. Similarly, const num equals 10. Const is an explicit declaration that we're creating a constant. However, the type of the constant is a string, and that's implicit. So, dynamic versus static typing. Let's say we have a variable. We're creating the variable implicitly, and we're assigning it a type implicitly. We're just saying x equals 3. Then, let's say after that, we decide to use that variable again and say x equals high. And then we use the variable again and say this time x equals new int 10. We're creating an array of 10 integers. Will this cause the program to crash, or will this just be fine? That depends on whether it's a dynamic or static language. A language is said to use static typing when type checking is performed during compile time, as opposed to runtime. In a language that is statically typed, variables carry a type. For example, in Java, if we create a variable, int x, here it's explicitly declared that we're creating a new variable, and explicitly declared that the type of the variable is integer, and then we try to assign the variable the string hi, we get an error message. Incompatible types, string cannot be converted to int. The advantages of static typing is that it allows type checking at compile time, allowing errors to be caught earlier in software development, and for code that runs faster. Examples of statically typed languages include C, Java, and Haskell. Dynamic, or also known as latently typed languages, they do their majority of their type checking at runtime. In a language that is dynamically typed, variables do not have a type really, but values do. For example, in Python, we can create a variable called x and put into it the floating point number 3.14. Then we can immediately instead give it the value 5 and have that be an integer, or put in the value hello, which is a string, and we can print it and we get hello. And this doesn't cause any problems because the variable x doesn't really have a type. Instead, the data inside of x has a type, and we can simply swap out the data inside of x for something else. The advantage of dynamically typed languages is they are flexible, easy to use, and allow for fast coding of programs. Examples of dynamically typed languages include Prolog, Python, and JavaScript. Duck typing is another type of typing. The idea here is that if it swims like a duck and quacks like a duck, then it's a duck. Duck typing is a form of type checking. It's used by Python for determining the types of objects effectively. For example, in Python, you just use an object the way you want to use it, and if that causes an error, well, then it was the wrong type of object. Let's try that out. So I have an object called myObject. I'm going to check if it quacks. Quack. Well, that's a good start. I'm going to check if it can swim. Nope, we got an error message. I guess it's not a duck. So to sum up, we learned to define explicit versus implicit declarations in typing. In implicit declarations, the language infers when a new variable is created. In implicit typing, the language infers the variable's data type. We learned to distinguish languages with dynamic versus static typing. Static typing, variables have type, and type is checked at compile. Dynamic typing, values have type, and the type is checked at runtime. Contrast the advantages of dynamic versus static languages. Dynamic languages are flexible and easy to use. Static languages have code that runs faster and is easier to debug.